Hi there, I hope you guys are doing great. I am Animesh and welcome to my YouTube channel. In this video, we are going to understand what is Spearsman's rank correlation. We are going to do some calculation of coefficient with steps, and then we are going to see how we can do the hypothesis testing using Spearsman's rank correlation test. So let's move forward. So basically, what is a Spearsman's rank correlation? It states that it determines the strength and the direction of monotonic relationship between two numeric variables. Now the question comes that is it a parametric test or it is a non-parametric test when we use Spearsman's rank correlation test? So it is a non-parametric test. And then the question comes that when do we apply a Spearsman's rank correlations test? So we apply it when the data is nonlinear or any one of the two variables is nonlinear. Okay. Now moving forward, the question that comes to our mind is that what is a monotonic relationship and what is a non-monotonic relationship? So as you can see in the graph, so specifically first talk about graph A, we can see that when x variable increases, the y variable never decreases. Hence, we can say that graph A is a monotonically increasing relationship. Whereas in graph B, we can see when the x variable increases, but the y variable never increases. So this is also a monotonic relationship, but it is a monotonically decreasing relationship. Now coming to graph C, we can see that when x variable increases, there are multiple occasions when the y variable increases and decreases. So it sometimes increases, it sometimes decreases. So now let us do the calculation of Spearsman's correlation coefficient. So I am now in an Excel sheet where I have two numeric variables. One is x and one is y. So we have all the 5 values of x and y, and I'm going to create one more column that is rank x and rank y. So this will give me the rank of each observation in x, and this will give me the rank of each observation in y. So let's just the correct values of ranking on x, and I'll put the values for y as well. Now I will create another column that is rank diff. This is nothing but the difference of each observation ranking with another. So it will be like 2 minus 2, 3 minus 3, 1 minus 4, like this. So let's just do that. And I'll do the same for rest of the observations. And now I have these values. Now I'll just square these values because I want square of rank difference. So it will be just, I'll just multiply it with the same value, and then I'll just put it for the rest of the calculations. And now I'll just take the summation of all the values. And now I got 18. Now this 18 is nothing but it is the summation of the rank difference, and this n is nothing but the number of observations, and these two values we will be requiring to put in the formula to calculate Spearsman's rank correlation coefficient. Now let's jump into the slide. Now here you see the formula for Spearsman's rank correlation coefficient. We denote it by rho, and it is equal to 1 minus 6 times summation of square of the difference of ranks divided by total number of observation into square of total number of observation minus 1. So this is how it is calculated, and we have calculated the di square summation and the n. We already have those values, and now I'm going to put this value into the formula. And now after calculating it, we get 0.1 as the Spearsman rank correlation coefficient. So this is how we can calculate it manually. Now coming to the hypothesis testing, how we can do that. So in hypothesis testing, the null and the alternate hypothesis are as follows. The null hypothesis says that the two samples are independent, and the alternate hypothesis says there is a dependency between the two samples, okay, or the two samples are correlated. So we will be calculating programmatically using Python the p-values, and if the p-values are less than 0.05 we reject the null hypothesis, but if it is greater than 0.05 we fail to reject the null hypothesis. So now let's jump into the Jupyter notebook. So here we are, and we are going to use the same data that we used for calculation in the Excel. So I'll be importing certain libraries like pandas, numpy and cpon, and I'll be just executing this data. And now let us just plot the data using a scatter plot to just visualize the relationship between the two variables. So by looking at the plot, since the data is very less, but still we can see that there is slight positive correlation between the two, but it is a very weakly correlated. But let's just be doubly sure using the Spearsman's rank correlation, because without doing the hypothesis testing we are just drawing the insights only. So here I have imported Spearsman's R function using the scipy.stats library, and I'm going to call this function and I'm going to pass these two variables, numerical variables in it, and I'm just getting the p-values and the stats, and I have created a if statement whether if the p-value is greater than 0.05 we fail to reject null hypothesis. That means the variables are independent, and otherwise we reject null hypothesis and the variables are correlated. So let's run it, and as we see that we fail to reject null hypothesis because the p-value is much greater than 0.05, and we can say comfortably that the variables are independent. So in this video we learned what is Spearsman's rank correlation. We also learned how we can do calculation manually. We also learned what is a monotonic type of data and what is a non-monotonic type of data, and where we can use the Spearsman's rank correlation. We learned how we can do the Spearsman's rank correlation using hypothesis testing programmatically. So I hope you guys learned something in this video, and please do subscribe to my channel. I'll see you in the next video. Till then, bye bye.